You want me to
Always
just
fast.
start? Okay. Want me
With
to
the cloud.
begin?
Yes.
Okay. Well, I want to thank Zidon and Hal for inviting me to do this data science workshop. We'll call it that. It's a pleasure to meet you all and be involved in a subject that I'm very fond of. I have done informatics for many years, but in the last roughly 6 years, I've started to look more at data science. Why? Because I'm the reviewer for a lot of medical journals, and I've realized that to review them, I need to know something about data science, machine learning, AI, and basic biostats, you name it. So to be a better reviewer, I had to expand my own education. I do want to say, though, at the beginning, I'm really sorry to hear about the floods in Australia. Last time I checked, it was wildfires. Same sort of things are happening in the United States, and I'm on the Gulf Coast, so hurricanes is a major issue. Then along comes war. I can't tell you how I feel about Ukraine. I hope that everybody does their part in trying to support the Ukrainian people and the refugees. So that's all I'm going to say about it, but I'm just saying that's an extremely heart-rending subject. So, all right. Let's see. Okay, so we're going to talk again about applied data science. This quote is interesting because if you go back to the 1920s and 30s, probably worldwide, oil fueled the economy, not data and electricity. So now data and high tech seem to be some of the driving forces. In terms of learning objectives, I'm going to compare the definitions of health informatics and data science and discuss some basic stuff about data science and how it interacts with the health sciences, if you will. Also talk about data literacy, which I would consider basic data science. What does it mean? What does that mean you should know if you're a healthcare worker? And I'll discuss several tools. I'm going to focus today on Orange, simply because it's so easy to use, and I think you'll see why when we get into it. But I'll mention other tools as well. The main goal is to find tools that are easy to use, preferably free, and are intuitive. Learning objectives. Again, for the first half, approximately, we'll talk about lots of data-oriented topics and why that's relevant. Second half, I'd like to have a hands-on demonstration of Orange, and then leave adequate time for questions and thoughts of what you all would like to see accomplished. So the goal to me, and this is actually the second time today I've given this talk, was not necessarily make everybody a data scientist, but make them sensitive to the issues of data and become more data literate than perhaps they are currently. Now, definition, this came from AMIA for health informatics, is the science of how to use data, information, and knowledge, basically to improve patient outcomes, if you will. It is interesting, though, if you look at the United States Bureau of Labor Statistics, they don't include health informatics as a job description. That's sort of interesting. It's still trying to find a home, if you will. But notice that I highlighted data. The second is data science. Basically, forgetting this definition, it's really the multidisciplinary approach to data from start to finish, finding the data, cleaning the data, deciding which features are important, running a model, let's say, and then presenting it to whoever it was that created this project. So it's unlike a data analyst who focuses only on the analysis, this focuses on all processes. Interesting enough, there is no national data science organization. So there is no formal definition of data science. By the same token, if you want to hang your shingle out and say you're a data scientist, you probably can, because once again, no formal definition. Now, I threw this in here for a reason, particularly if a lot of people are research-oriented, data scientists, computer scientists. We always have to remember what is now the quintuple aim of healthcare. It started as the triple aim, then it became the quadruple aim, and then very recently, the American College of Cardiologists suggested health equity be added. So when we start talking about really cool data projects or research projects, we have to remember they really ought to have a meaningful outcome. These 5 should be our guiding light. Okay, what is data science? Good question, since there's no formal definition. First, I'll start with where I think it fits in. So this is biomedical data science because we're talking about healthcare and medicine, but this could be finance, this could be any other industry. In the center, you see biomedical data science. It's really the center of 3 overlapping circles. One of them is computer science, which tends to focus on programming and technology. Mathematics, statistics is actually vital. I don't care what anybody says, machine learning, AI is all math-based, be it linear algebra or calculus, it's math-based. And certainly statistics is as well. And then domain is important. You all are domain experts as clinicians, and you provide invaluable input for any kind of data project because you don't want pure technology, but by the same token, the average clinician cannot design a technology project without the expertise of others. But the input of the clinician is paramount for any project that involves data. Now, this I put together simply because you might say, well, where does data science and computer science fit in? Right now, they're separate but equal, and there's overlap, and nobody cares to define it any further than that. Will they eventually blend together? Maybe, I don't know. And then artificial intelligence falls about there. Remember that it began in the 70s as expert rules. It wasn't very fancy. It was just if-then rules. If a patient in the ICU has dropping blood pressure, elevated pulse, temperature creeping up, they're probably septic. And so you have rules, particularly for antibiotic use. Then came along machine learning algorithms, which actually have been around for 20 or 30 years, not the newest ones, but they began to be developed. And then neural networks has been the major algorithm that's appeared. And then when the neural network has more than several hidden layers, it's called deep learning. And deep learning is what has been such an unbelievable change in the landscape. Every program that does image recognition or natural language processing, it's all deep learning, neural networks that are complex. Okay, who handles data? And I can't speak necessarily Australia, so let me know about this. But if you talk about doing just basic descriptive statistics, or perhaps using spreadsheets and maybe moving on to relational database, some clinicians can do it, certainly statisticians, your hospital data analysts, QI people, perhaps some informaticists, and some HIM professionals. But if you start talking about predictive modeling, it's going to be generally statistician and data scientists. I will tell you, though, with Orange, it could be everybody that's on this call today. It would be quite easy for you to develop a predictive model. Now, in terms of big data and true AI with deep learning, that's a domain of largely data scientists and computer scientists. Where are we now? This, again, is highly simplistic, but the idea is if you're a small hospital, you probably have doctors, nurses, perhaps a data analyst, maybe not. But as you get larger hospitals or healthcare systems, you may either have a full-time data scientist or you contract with one, and you start using more of the tools that I've outlined, such as program languages. And then there are large hospitals, and I'm going to only cite the United States, the Mayo Clinics of the world, Stanford, and so forth, where they have all the bells and whistles. The Mayo Clinic has a division of everything. I commented that they have actually 2 AI divisions that deal with cardiology. One is genetic oriented, one is not, but that's fairly unbelievable compared to small institutions. And my heart goes out to the small hospitals that simply don't have some of these bells and whistles. Now, the challenge is that there's a shortage of people with this kind of knowledge, particularly those that have clinical expertise as well as data science expertise. And it's unclear how much is being taught in health informatics and clinical informatics program. I did a formal look at this 5 years ago, and it was very little. One of the obstacles is the centerpiece to data science tends to be a programming language of R or Python, and in addition, SQL to access relational databases. Now, learning a programming language to do basics is really not too difficult. That's something I'd be happy to do in a session. The basic simple things of exploring your data, and with some of the newer auto ML programs, they do an awful lot with only 1 or 2 lines of code. But if you're talking about using image recognition and you're going to develop a convolutional neural network, good luck, men and women, because you're looking at 40, 50, 60 lines of code, very complicated for that, or natural language processing. So to my way of thinking, if you're trying to influence the rank and file, you need some other kind of program that's easy to use. Free works for me, comprehensive, intuitive, and very usable. Some have called that the democratization of data science, if you can come up with something like that. And it would allow for more clinician data scientists who are in fact more data literate. So this ideal platform would be able to do basic exploration, which I would say is certainly part of data literacy, but it would do supervised and unsupervised learning, image recognition, and text mining. Current choices: get a master's degree in data science or biomedical data science. Do all the courses on your own, which could be done if you're a quick learner. You could learn to program on your own. I don't recommend it unless you have a programming background. I can't tell you how important it would have been for me to have a mentor looking over my shoulder and say, you skipped a semicolon, you skipped a parentheses, because believe me, you can spend hours trying to figure out what's wrong with your code. SQL is much easier to learn, and that is actually a module that I plan to teach my workshop in the US. Okay, software I didn't put here, and I should, is there are stats packages. I'm going to mention 2 open source free packages, that one of which includes machine learning and is doable. I do not like it as much as Orange, however. Okay, this is just sort of refresher for those people that don't have good knowledge about machine learning. Machine learning now is pretty much synonymous with doing predictive analytics. And supervised learning, the way you think about that is, you know what the outcome is, you're just trying to predict it. So if you're trying to predict a biopsy being benign or malignant, you want it, in other words, you want the machine learning, or AI in this case, image recognition, to classify it as benign or malignant, that would be classification. Or perhaps a better example would be, you're trying to predict whether somebody's diabetic, pre-diabetic, or normal, and you have all this lab work and other parameters, and so you're trying to predict diabetes, yes or no. That would be classification. However, when the outcome you're trying to predict is numerical, that's regression. So example would be hospital costs, length of stay, and so forth. Unsupervised learning is very interesting and not used all that much, but should be. And that is when you don't know the outcome and you simply want to turn loose this artificial intelligence to look at this data to see if it can find groupings we call clusters. This has been used for a good number of years for genomic associations, where let's say they have a gene and they want to see how it aligns with phenotypical things: age, gender, ethnicity, lab work, you name it. Association rules is the same thing as market basket analysis. In other words, if you order something on Amazon, down at the bottom it'll say customers who ordered A ordered B. You can use this in medicine. It's not used very often. It's fairly easy to do. Principal component analysis has been traditionally a statistician's tool, where if you have too many predictors, let's say in a spreadsheet, you have 300 patients, but you have 300 lab tests or predictors, you need to shrink that down to make the model work better. Well, PCA is one way to do that, but we won't get into that kind of specifics. Okay, the skill set for a data scientist, you notice at the bottom of this pyramid, programming, because they use it for data preparation, the analysis to create the model for machine learning, AI, and they do have a pretty good background in math and statistics. I do want to point out that number 3 here is soft skills. It's often forgotten that a good data scientist has to talk to doctors, nurses, the command suite, and when all is said and done, the model's created and whatnot, or whatever the data project is, they have to present it, and it has to be understandable. And so they actually do a lot of talking to clients. But that being said, they do not spend a majority of their time doing cool things such as picking algorithms, tweaking algorithms. Nope. The most of their time, 75% or more, they have to find the data. They have to curate, clean the data. I call that being a data janitor. They explore the data. They do feature engineering, which simply means you pick this variable, you delete this variable, you combine these variables. That's feature engineering. And that basically, when you look at the data science process for either you all or a data scientist, this beginning point is exploratory data analysis, where you get to know your data. You literally do explore it with visualization, descriptive statistics, and basic techniques that everybody should understand. Then you move on to more complicated things like predictive analytics. And then sort of the holy grail is, if you know those, you can move on to AI, which is indeed much more difficult. It's not difficult to understand how it's used in, for instance, radiology, cardiology, pathology, and ophthalmology, but to get into the actual technology and to basically peel the onion back for a convolutional neural network, good luck. Again, it can be done, but it requires a tremendous amount of time. So a lot of time when you're talking about predictive analytics in machine learning, you're building a pipeline. This, I hope, will be obvious when you look at retrieving data, then you process the data. Wrangling just means you're cleaning and playing with it. You're getting it ready for the model. In the model, you're introducing multiple algorithms, and you're coming up and you're testing it, and you're also coming up with outcome or performance, such as what's its sensitivity and specificity, as an example. Maybe it's not as good as it should be. You can tune the algorithms, but you may have to go back. Notice that arrow at the bottom. You go back and tweak stuff. You may delete some of your variables and then run the model again. And ultimately, you deploy and monitor the model. Now, let me get on my soapbox for 1 second and say, unfortunately, most of the literature talks about proof of concept models. Most are not deployed yet. Most are not associated with a prospective trial. So that's a criticism of predictive modeling and predictive analytics, is everybody's, publishing their results of a model, but very few people are actually deploying it with real world results and real world data. Now, data literacy, I'm really kind of ad-libbing this. You should understand data, be able to visualize data, but I'm going to give you my own kind of viewpoint on data literacy. Why? To me, it's the starting point of data science, and I would encourage people to try to be more data literate, and let's just talk about what that means. First of all, there is data in every industry, including the sports industry. And I think data literacy is like any language literacy or computer literacy. It helps to have that feather in your cap. The basics are needed before you move on to machine learning, artificial intelligence, or you review medical articles. Now, I don't think in Australia this is an issue, but I had it for a previous talk where supposedly they're going to require electronic health record companies to use the data standard FHIR and have in FHIR API. So now you can request data out of the electronic health record. If that's the case and it's successful, it could open up data being mined on a regular basis from an electronic health record. So when we talk about understanding data, how about we need to understand that 75% of medical data is unstructured? How about we understand medical data is very messy? Everybody uses different acronyms. Also, M could mean male, it could mean other things. Hemoglobin could be HEMO, HGB, you name it. So data is very, very messy. And on top of that, if you try to teach data science or you do research, you know how difficult it is to get patient level data because of HIPAA. For research, a lot of people use MIMIC, that's ICU data. I would argue for primary care, the NHANES, NHANES data is very good. And we can discuss that later because that is patient level and available without any kind of special training or secret handshake. So I'm going to give you a couple examples of what I mean by data literacy. Understanding the different types of data so you know what you're dealing with, how that applies. I mean, when we talk about visualization, a histogram, for instance, that's numerical data. And I'll go over that when we do orange. Why isn't a distribution important? Well, you're supposed to have normal distribution if you use linear and logistic regression, but also if you look at the last line, 99.73, that's 3 standard deviations. Anything above that, most people would agree is an outlier. So that's one of the definitions. But understanding distribution is really important. When you talk about a model looking at benign versus malignant or 2 different classes, if the model does a fantastic job, the distribution of the 2 classes will not overlap. When they overlap, that's where you get your false positives, false negatives. So understanding a little bit about distribution is important. I suspect you already know about correlation versus causation. Most of the retrospective studies we do in models bring up interesting correlations, but that's not causation. And this slide reminds you that sunburn does not cause ice cream or vice versa, at least the last time I checked. And then again, just the general stuff about structured versus unstructured is important. Structured data is anything that fits into a spreadsheet or a database, such as results of the serum cholesterol or creatinine level, and that other things don't. And then there's semi-structured data like JSON and XML. I won't get into any great details here, but just to understand, again, we already said that most small hospitals do descriptive. We're pushing that you know how to do predictive because it's not that difficult to do the actual model, and prescriptive is more complicated. That's where you actually have the ability to come up with multiple options of what you're supposed to do, but it requires a team and an extra software and so forth. So these are just examples of what I would say is data literacy. Then when exploratory data analysis, this is more prep. You need to ensure it's the right format. You have to know how to deal with missing values because there's multiple ways to do it. Outliers I mentioned. And then you have to do a little bit of wrangling with the variables. Which ones do you delete? Which ones are important? Which ones aren't? Descriptive statistics is just basically statistics, looking at distribution, mean, mode, range, dispersion, counts, and once again, do you in fact have missing data? And then talking about some of the bare minimum tools, some people in AI kind of badmouth spreadsheets, but in my opinion, having basic skill with spreadsheets is a great starting point. I don't use some of their functions like you can do, to my knowledge, like linear regression and t-test in Excel. I don't think it's user-friendly at all. I don't even think their pivot tables are user-friendly. I think there's better ways. And I just will remember in passing about, or comment in passing about Jamovi and JASP. It might be worth one session or one Saturday to present it to why I think it's really good. If for no other reason, not every hospital can afford SPSS or SAS. I don't know what you all are using. It's certainly a mega program that's excellent, but it's not necessarily a great program for a newbie or a small hospital. And although Excel will do visualization, Orange does visualization, and the stats package do visualization, when you look at surveys in the US, and I don't know about Australia, Tableau seems to be the one they really like. So anyway, Orange is the one we're going to present, but just make you aware that others are available. And I always say it never hurts to have lots of tools in your toolbox. Okay, data visualization. Again, it's just the ability to know, oh, I've got numerical variables. I need to do a histogram or a box plot. Categorical, I need to do a bar graph or a pie chart, and know what some of these mean. And perhaps you need to create an interactive dashboard using Tableau to present to your management. Those are just some ideas of that. We'll show this with Orange in a second. So we're getting pretty close to the end of this presentation. So what is Orange? It's a data mining or data learning platform, all based on Python. You don't see Python, but it's what's working for you in the background. It was designed by computational biologists at University of Ljubljana in Slovenia. It's used worldwide, not so often in the United States, but I swear, I think the biggest reason is people simply don't know about it. So we'll show you why it's easy to use and give a demonstration. And I think you'll agree it is in fact easy to use. I've used it now for about a year in the United States to teach clinicians. In terms of the features, it has modules. Those ones above, like data and visualize, are the ones that automatically, but it's easy to add the others. So it does lots of other things, particularly for the computational biologist. So it will perform all the major categories of data science I think anybody ought to know. The workflow on the left, you'll see a menu that explodes open with lots of widgets. You drag a widget onto the canvas on the right, you connect it, and voila, you have a data science project. I do have an ebook that's free that I give to anybody that basically these are the chapters. I'll just skip down a ways and tell you that I do have one on databases. Many of you have probably never heard of bit.io. I took a long time finding this, and it was by accident. It's brand new. Most databases, if we want to use them for education, are a pain in the butt. Why? You have to launch a server, you have to synchronize it, you have to be a database person to use the database. That's not what I want. I want a platform where you have absolutely no experience with databases and you can use this. And it makes teaching real simple SQL fairly easy. And the last chapter I put together is not related to Orange. It's simply reviewing what are international guidelines to suggest what is a good machine learning project or AI project. Therefore, if you know that, it helps you read the literature. Okay, with that, I think I'm done with this segment. Now we'll see if we can perform some magic and actually find, let's see what we got. Let me see, do you all see that?
Yeah, we see your browser.
Okay, but do you see orange?
No.
Yeah, that happened before today.
So just switch the screen sharing to orange. Sometimes you have to do a new.
I probably need to stop share though, correct?
Yes.
Okay. So then go back to share, right?
Did everyone download Orange, or does anyone need help with downloading it?
Sorry, I haven't downloaded it. My apologies.
That's okay.
All right, let me
It's
see.
orangedatamining.com. I've
Now,
downloaded it, but I've not installed it yet.
Yeah, and download it, by the way, from their website, not from Anaconda. Just way more complicated. Now, do you see it?
Yeah.
That's a yes?
Yes, yes.
Yes, we see it.
Okay, all right. Okay, I'm not going to go through every detail because if this is what you all would like to go over, we're going to spend a lot of time, but let's just suffice it to say, it's organized like this. Basically, in data here, you have the ability to just pick what rows you want, what columns you want. I'll demonstrate the data sampler in a minute and the data table. They're very cool. But basically, you drag stuff out and you connect it. Let me show you data sets, which is fairly cool. Now, here's going to be an issue, though, how I get out of here. There's an icon. But basically, Orange comes with 65 data sets already. All you have to do is double click on it, connect it and double click it. It tells you what it is. It even tells you where it comes from and gives you extra references and advice, okay? So that's, available for you in the data section. The file widget, and I'll open that, and hopefully, again, we can get out of it. You can, first of all, just go to your desk or wherever you store your data and upload it from here, but you can go to a URL if it has like a CSV file on it, and it'll download from that. But here it tells you all your variables. It says you have 13 features, 0.2% missing. It's a classification, categorical class with 2 values. Why does it say that? Categorical 0 and 1. And I made this the target. In other words, target means the outcome, if you will. Features are the predictors. And unfortunately, we'll talk about this. The computer scientists and the statistics guys never got to go together over a beer and came up with terminology that was the same. And even further, whoever did put this data set together, rather than calling this the presence or absence of heart disease, they call it diameter narrowing. That means that the people who had a cardiac catheterization and had coronary narrowing greater than 50% were labeled as 1, heart disease. If they didn't, they were labeled with 0. Now, everybody knows that's probably not completely right. But it's a good model nonetheless. That's what we'll deal with. So basically here, up top, and there are many more, but you just go down. Let me close data for a second. Just go down to visualize. And if you want a box plot, you just drag it out there. And let's open the box plot because there are some interesting things about it. And again, I'm remiss in not thanking Zaidan for the beautiful job he did on customizing the presentation. That mine was very vanilla, and it kind of looked like somebody my age, and then Zaidan turned it into something that was much more high-tech, high-speed. So I have to thank him for that. So here's an example. Let's start with numerical, because what's interesting about this box plot, unlike any box plot I've ever seen, it'll do numerical and categorical. So now let me let somebody in. So if, for instance, let's do down at the bottom, the subgroup is diameter narrowing, heart disease, yes or no. And where you find that, if you look up here, 0 and 1. So this happens to be, let's look at, this is unimportant, but let's just pick on this one, numerical age, but you're trying to look at it based on heart disease. In other words, is there a difference in the age between those people with and without heart disease? So here's your box plot. This is the 25-75% interquaternary range. So you got mean here and median here. If there's much difference, it's not, the distribution's not normal. We'll talk about that in a future class. But what's cool about this is, notice, you may say, well, I don't know if that's statistically significant. Yes, you do. Here's your t-test. P equals 0.000 whatever. So it automatically gives you that. You can look at cholesterol, same thing. And you could do cholesterol by gender. So you just pick a different subgroup. So, again, this is a great way to explore data that's painless. I can't think of anything else that's this easy. And that's, again, why I selected it. And you can do that for much of anything you want to do. We could do it, the number of coronary vessels that show calcium, or you could do thallium. Now, this is what I wanted to show you, though. In this case, thallium is a categorical variable in 3 categories: normal thallium stress test, reversible defect found, or fixed defect found. So what's cool about this, and this is just one data set, and I don't want to make too much out of it, but notice that there are a lot of people with heart disease that had a normal thallium stress test. That's no surprise to a cardiologist in the sense we know how tough it is to pick up heart disease sometimes, particularly in women. But the point is, none of these tests are perfect, but this really highlights it, I think, extremely well. And even the chest pain will do this. Ironically, and again, I don't know enough of the details, so we're not, this is not something we plan to publish, but notice that they labeled with people with heart disease were more asymptomatic. The people, because I think they were all picked up due to chest pain of some type. Now, this may mean asymptomatic on their stress test is probably what it means. I don't have the original study. I can't comment further. The whole point of this is to say, look how easy it was to look at the categories based on heart disease, yes or no, to think about this further about what you want to do with this data set. That's all I'm going to make out of box plot. Scatter plot, again, what's kind of nice about it, you can put in here a regression line. So if you're looking, I think we've got age and cholesterol, you can see over time, cholesterol went up with age. It already, because you can, again, select the color for subgroups as diamond and narrow, mean heart disease, yes or no. So the red is heart disease. So it's really that easy. Let me see. Distribution. And you can change this. So this is resting blood pressure. We can make it cholesterol. And you, with all of these, you can pretty well, I guess I should have done this with the scatter plot, but if you have an outlier, you can click on the outlier and it'll tell you exactly what patient, which group they're in, and all their other lab tests. Save you a whole lot of time. For instance, anybody want to guess? This is somebody with a cholesterol of almost 600. Any ideas? You can unmute if you want and spit it out.
Homozygous familial hypercholesterolemia.
That would be my first thought, except what if I told you it was a 60-year-old lady without heart disease who has an extremely benign profile?
Just an anomaly?
I think hypothyroidism would be my first choice. But the point is, she probably has secondary hypercholesterolemia, I think. I mean, my feeling would be if she had one of the bad genetic disorders, she probably wouldn't be here or would have heart disease on cardiac cath. That's my opinion. Again, that's not the point of this.
Sorry. Yeah. I was going to say the first thing I do is go and check whether that result was accurate or not, if I have the data.
Absolutely. Yeah, I didn't mention. You're absolutely right. You pull the chart before you delete that patient. I mean, you would absolutely do a chart review. You would look at her prior cholesterols. Were they all that high? All the above. You're absolutely right. That's the starting point. I'm just being kind of cute, Bob, saying, what's the differential diagnosis?
Sorry, Bob, I think just on that point, on the distribution. So just to show everyone, if we just make a table and link the table to distribution and click on it, just to show you the actual power of this. You know, if we make a table, if we make a table widget and then link the distribution to it and click on the patient, it will highlight it in the table, right?
Correct.
Yes. So let's just do that because I think that's very interesting for,
Yeah, and let me see though. I don't think it would be this widget. One of the others.
Some widgets.
Yeah, so one of the others, you click literally on the outlier and gives you all the information you need, tells you who it is, the whole bit. So, but let me see. It may be, let me see, we have correlations, feature statistics, pre-rank. Let's look at.
There's your outlier at the top in the blue dot at 560. She's
Yeah,
right at the
and
top.
it's buried just a second. Oh, there it is. Say it, my menu. So let me see if that point of fact. But you can connect, there you go. But you can connect that, just as Zaidan said, you would then, you highlight that dot and you connect it to a data table. And we're going to show you that in a second. That this is one of the unique features. There are 2 or 3 features about Orange that simply don't exist anywhere else that I know of. And this is one of them. Anytime you're interested in a data point, you can mouse over it. But again, you connect, or anytime, let's say you change data, you did something, you normalized it, you standardized it, you did something to it. You then connect a data table to it, which is like a little Excel spreadsheet. And you say, who was this patient? And you can look at all of this and you can manipulate it a little bit. But the point is, the data table is what you insert if you want to look at your data. Does that make sense? So you could, a lot of people would put a data table here in point of fact to be sure they know what they're looking at. Let me move on because the chances are we're going to be looking at all of this again. So feature statistics might be one of the first ones you start with actually, because this gives you, again, and sorry, my menu's in my way at least. So you look at the classes, they're almost as many people with heart disease and not heart disease. When there's a big disparity, you got trouble. We will go over that. But the point is, that doesn't exist here. They're pretty equal. But again, you could look here at age, maximal heart rate, which is the heart rate on their stress test. There's lots of stuff you could look at that would define things further. No surprise that the number of millimeters ST depression was seen primarily in people with heart disease, but there were some people that had ST depression who didn't have heart disease. No surprise. But again, this is a good starting point, if you will, for some descriptive statistics. Not as good as the stats package, but again, for that quick look, that data literacy look, I'm going to call it, I think it's perfectly adequate. Correlations will automatically come up with correlations between variables. Notice that age and maximal heart rate, basically those people as they got older, their heart rate on the treadmill was far less. So this gives you some, this is a Pearson correlation. You can make it a Spearman. So this is the correlations based on age. You can pick up others. And some of these even give, it says, find some interesting relationships. So it'll do it for you. Now here's where I hope I don't get into trouble because trying to exit out of it, I may have to hit escape and hope for the best. Yeah, when I did that before, unfortunately, I got a black screen. So let me stop share and try it again. So that's the only problem sometimes. But anyway, can you all see the screen again?
Yeah.
Okay, all right. So pre-process basically lumps together a bunch of things in one widget, or what you might call an app. For instance, if you want to make continuous number categorical, put them in bins. If you want to take other things, if you want to take discrete variables and turn them into numbers, that'll do it. If you want to impute missing values, it gives you several different ways. You can select the relevant variables for you, normalize, randomize. So the point is, it does all kinds of stuff all in one widget. So you just click here, double click, and there it is. So it's really incredibly user-friendly. So here's the algorithms, but you could, in fact, let's look at the algorithms. It's under model. So you could do a simple tree, which is often a good starting point, but you can do more complicated trees, boosted trees, including XGBoost, which is the favorite, random forest, which is certainly good, linear and logistic regression, naive Bayes, neural networks, a standard kind of generic neural network. So all you have to do is drag them out and connect them to test and score. If you want to see how your algorithm, here we go again. If you see how your algorithm did, now this is on training data And you can add, just click on,
Bob, it's just a white screen
White
now.
oh, okay, sorry. Anyway, this is where you'll see sensitivity, specificity, area under the curve. Let me see what you see here. You see that, I'm assuming, the rock curve that,
I'm showing you.
okay. And then one interesting feature that I hinted at was being able to see, do you see a confusion matrix?
I think you're sharing just the window rather than the screen. So when you're changing to another window, it's not coming up for us.
Yeah, okay. So that in class, we'll have to figure out some way to get around that. But to make a long story short, in a confusion matrix, you're able to see how many false negatives, false positives and false negatives you have. You can highlight that by clicking on those. I clicked false negatives because you don't want to miss people with heart disease. So, well, here, is that a white screen again?
So Bob, maybe
I would
just stop the
just stop.
sharing.
Yeah.
I mean, I'm not sure if it's the same on a Mac, but just stop sharing.
Yeah, the option I have is called new share.
Just stop sharing. Just stop the share at all. Just to make,
Okay.
and then make a share. But rather than use a window, then I don't know if in a Mac there's an option to use a segment of the screen, which is the whole screen.
Let's see what it says. Well, what I'm wondering is, I wonder if I should go back to desktop instead of orange. Any idea?
No, just try that. Just share screen and
Okay, but I have the option to share desktop and I have the option to share.
desktop. Yeah.
Yeah, let's try
Okay,
desktop.
desktop.
Just
yes.
the screen is your desktop.
All right.
Yeah.
Now you see orange.
Yes.
Okay, let's open one and see if you can see it.
Yes, we can see it.
Okay, so the point, what I was saying is, see the blue, I double clicked and highlighted it, is specific for logistic regression. You can do a confusion matrix. That's how easy it is. And people can actually compute their own statistics off of this, which really makes it easy. So let's open up the performance, which I think is really cool, that it gives you this. And what I was going to show you, you can add stuff. Okay, specificity is already there. Okay. But here, if you're doing a classification, you're generally going to look at the area under the curve. You're going to look at precision, and recall is sensitivity. Precision is also positive predictive value. And all that means is, of your positive, what percent of them are truly positive? So precision is actually a fairly good term. And whereas specificity is all about your negatives. But the point I'm going to make is, let me see if I can get out of here without killing something, is watch how easy this is. Insert widget. And I'm going to put on here data sampler. Click it, open it. It's not going to prove me a liar, I hope. So you're splitting it into 70% train, 30%. So you just drag and drop another one over there. So the training data is the data, the test data is the test data. So when you click on this, you go down, first of all, you need to set here that your target class you're most interested is the people with heart disease. You could look how well it predicts people without heart disease. But if you want to look on test data, you just click that, it recalculates. So the point is you can look at both test data and training data. I don't know of another program that does it. Even the other programs do one algorithm at a time. So you have to write all of this down in essence. Whereas here, what I normally do is an entire menu of algorithms. I'll put XGBoost in there, SVM, you name it. We'll try all of them and see which one performs best. So that's unique. And also the ability to toggle between training data and test data to see how it's going That's unique. And thirdly, the ability to hook a data table up so you can see exactly what you did is pretty unique. Let me try one more. Here, can you see a new one?
Yes.
I hope, okay. So
Yes.
here, so this is image recognition. So I imported images on my computer, 15 people with early diabetic retinopathy, 15 people that were healthy. Very high resolution. That's why there's only 15 in each class. This is obviously a toy set, but the good news is it's very high resolution. So that goes to what they call an image embedder. Not such a great term, but what it means is, you know, computers don't read images, they read numbers. So that image is converted into numbers using deep learning. And this particular algorithm, as you open it up, we use Google Inception version 3. That means nothing to you, but that's a very good algorithm, deep learning algorithm that actually is being run on Orange's server than back here. But it's surprisingly fast. So what we're trying to do is how good is it in interpreting normal from early diabetic retinopathy? So that's actually a classification, supervised learning. You know what you want to predict. I happen to just pick 3 algorithms. I could have picked others. So once again, here we go. So it actually did very well, other than, oddly enough, gradient boosting did not do as well. And you can, again, do training or test. But what I wanted to show you is, once again, confusion matrix. And so I selected here, notice at top, predicted, and here actual. So it did mess up. Let's look at, let's see, it predicted healthy, but actually they had diabetic retinopathy. Okay, so I highlighted it. And this is kind of large, so I guess I can make it smaller. But you can then go over the image and see if it was right or not. Pretty dramatic. For instance, it missed a small dot hemorrhage. But my point is, look at the flexibility of that. It was very easy to create it. There are a lot of images, repositories on the internet. So I've done chest x-rays, I've done dermatologic images, EKGs, you name it. So I mainly wanted to show you this to some degree. The icing on the cake is try doing this on your own with another program. It would be very difficult. Okay, I've talked long enough. Let me stop and start entertaining questions, and even better would be discussion of, is this useful? Would you feel that you would gain benefit by going over these different sections and getting more familiar with how to do exploratory data analysis, how to create a model, those types of things. So let me shut up and entertain. I see a raise. Zidane, do you want to moderate those? I mean, we can unmute anybody. It'd be great if they would just, we could hear what their question is.
I think, I mean, we're such a small group at the moment. So I think everybody's, sure, raise your hands, but everybody can unmute if you want to say something. And yeah, raise a hand. And I think it's best to make it a discussion. I mean, there's only probably 10 of us.
Farhana has a comment to make.
Yeah.
Yeah, thanks. It's more for the second part. I don't have a question, but I do have a comment on. So I've got I've got zero experience, no programming knowledge, no math, stats. I'm a clinician, specifically a radiation oncologist. But this has been fantastic today, and I would get a lot of benefit from learning how to use Orange. But I probably need a little bit of help. I'm not as intuitive. So, but I'm also happy if others are more advanced, and I hold people back to not do so much, because whilst it would be preferable for me to learn it, it's not essential.
Okay, but let me just comment that we go very slow. In other words, the first session is just getting used to Orange and, navigating around. And then we get into a whole session on visualization. So that's going to be an hour, 90 minutes on just some of these widgets. I think there's enough time. And then I make a lot of data available to you. For instance, if you go to my website, and I probably ought to put that in chat, I now have a file share download site for different, so there's a copy of the book there. There's a bunch of medium-sized medical data sets you can download and play with. Also, from one of my textbooks, I copied out the appendix on helpful medical data websites that you can also use. In other words, if you say, yeah, I want to really do my own search for medical data websites, where can I find them? It's there. So let me put in the chat what my website is.
I've downloaded Orange now while you were talking, and I'm happy to do homework kind of stuff to prepare. So yeah, I'm going to mute so others can also comment.
I was just going to say that I think to make the classes helpful for people of all standards, I don't know what other people's thoughts are, but if we all use the same data set, so that we can all follow what each other are doing and then just practice all the different parts of Orange with the same data set as each other, it means that we can go at our own pace and our own level, because if we're more advanced, we can add extra widgets and stuff. But if we're just at the basic level, then we can all go for the basic level, and then other people can play around if they're a bit faster. But that way, people that are entirely new to this stuff, like Farhana and I, can go with you, Bob, and then other people can play as they get faster. I don't know, just a thought.
So I think one thing I was thinking about to answer that actually is two things. First, one thing good about Orange is that the workflow that you see in front of you can be shared. So Bob can share it, and then we can all import it and just have exactly the same workflow that he does, and the same thing with everyone, which is one of the very cool things about Orange. The other thing I was thinking whether we should spend time to build this from the ground up. Say, for example, we have a blank canvas. We click on the data set, select the data set, etc. Just, that kind of really slow step by step. It will take some time, but Bob, do you think that's worthwhile doing?
Oh,
Does everyone think that's
absolutely.
worthwhile?
Yeah, I mean, again, I'm a hands-on guy. I jokingly say I'm the Mike Rowe of data science. Mike Rowe's a guy on United States TV that does all kind of dirty jobs, and he's always getting down, into the ditch, so to speak, to figure out how something works. Well, that's what I do. And so there'll be plenty of time to start with the very basics. I think you'll find it easy. In addition to that, I add a lot of extra content in every chapter. There's also a resource section. There's a homework section. There's all of that. So don't worry. I think you'll find this surprisingly easy. I will use only medical data sets. I will use this heart disease data set several times, but I'm totally open for using other data sets if you happen to have access to a CSV file. But we have tons of data, by the way, that we can use to do simple regressions and modeling and you name it. But we definitely want to start with the simplest basics possible. And lesson one, that's all we're going to do, is make sure everybody knows how to navigate and use it. There are plenty of bells and whistles that I'm sure I haven't mentioned. Zaidan already mentioned that you can save this as an Orange file, OWS, I think it is. And basically you can send that to somebody, they open it in Orange, and they got everything that you're seeing, for instance, right now. So there's a ton of, in fact, when you save Orange, it saves it to your document file. Save it with the name on it, whatever that happens to be. And so the next time you come in, you open it and you're right back where you were. So there's tons of bells and whistles with this program that we'll go over. But it's really more, do you see value in this? Do you see orange as something that would help you be a more knowledgeable clinician? And if the answer is yes, then we'll move forward.
Absolutely, yes.
Yeah, Bob.
I 100% agree.
Okay, and you want to shoot for, I don't have the date. It's not the second weekend in April. I think it's the third Saturday, but regardless, we can shoot for 90 minutes. I like to go slow and make sure and interrupt. The beauty of a smaller group is the ability to unmute and say, wait a minute, stop. Why did you do that? What does that mean? Because that's real important that you all, it's just as important that you understand what the widget is doing as it is to understand orange. In other words, to be able to visualize outliers and to think about it. The comment about going back and looking at the chart is exactly the right answer. We'll go over the data and say things like that that are unrelated to orange, but they're sort of significant as a clinician or scientist. What would you do? I mean, the same is true of missing data. There's no easy answer. You don't delete all missing data. So we'll spend some time on that and review the literature a little bit. So I've tried to if you look at some of the textbook chapters, you'll see a whole lot of content in there you're not going to find in orange. It's supplemental stuff I added to make the content make much more sense. How about other comments or questions? I have not looked at the chat. I'm just waiting for you all to unmute.
I'm looking at chat. Thanks, Baron. Baron is uploading this. One question I have is, Bob, and that's a question for everyone actually, is, as you can see, personally, I having been trying to find something that works for many years, I see nothing like orange, absolutely nothing. And it's a lot to get your head around, because you get your head around not only around the way orange works, but also around the concepts behind it, which is the most important part to us, the precision, the recalls, how to make it work, all this sort of stuff. The question I have is, how do you, as everyone see, the time we spend the time in the month between one session or another? Like, the duration of the session is one thing, but having a little work to do in between is, I think, something that keeps your mind, your memory, sort of refreshed and helps absorb things. Because if we would wait from 1 month to the other, we would have forgotten a few things. Then we are hit with new things. I'm just trying to think what everyone thinks. I mean, should we make this the classroom, or everyone's happy just with hands-on presentations? The other thing is the number. I mean, Bob, we were keen initially to make it a small number so that everybody can ask whatever questions they have and, make it far more interactive. We may have far more interested people in this, and whether we have different sessions, I don't know. Just thoughts for everyone. I'm putting it out there.
I think keeping it small, Zaidon, is really great. Because it is so practical and hands-on. But I'm very happy to do some homework in between to keep up the skills before the next class. So if maybe we set a project for each other in between class that we can just practice through and learn each step before the next class, I think it's very reasonable.
Well, remember, though, that's the advantage of having that ebook. It's easy for me to say, be sure you've read the first chapter beforehand, as an example. So remember, you do have that ebook, which will go over more than just orange.
Yeah,
the first
with
chapter,
resources.
Yeah, I mean, the first chapter will be largely, getting started will be largely about orange, needless to say. But what I'm saying is, as you move forward, like on the data thing, I'll have a lot of stuff in there about data that is important related to orange, but it's not orange specific. You know what I'm meaning? So I think at bare minimum, we can assign a chapter ahead. And also, I have homework pretty much in every chapter, and we can talk about that. And I can expand the homework, but I would agree that, if you wait a whole month and you do nothing, you're going to forget some of this stuff. So it would be helpful to either do exercises or read the chapter or both in between for that 1 month.
That'd
The
be
other
our
option would
homework.
to make it fortnightly.
What's that?
The other option would be to make it every 2 weeks, just throwing it out there.
That's up to you all.
I am in favor of that.
All the
I'm in
teaching
favor.
commitments, Bob.
Well, I'm in favor if you do it every day.
Yeah, every day. Did I hear
Zidon, always the positive motivator. Love it.
it? Yeah. And I would say, crikey, mate, every day. Well, no, I mean, for that matter, you can talk among yourselves. I mean, I can probably do that. I think this time is actually pretty convenient for me. But we can see, why don't you talk among yourselves and look at the schedule? I mean, right now, I think Hal put us down for, I don't have it in front of me, in April something, but it wasn't the your second Saturday.
I think it's synced up to your American. I borrowed it from your American schedule, so that you basically teach the same session twice,
Oh,
every month.
you may be right.
Yeah. I mean that's where I got the numbers from. So
I got you, because the problem is my workshop, I have one tomorrow, sometimes happens when the board review course goes on, and I have to bump it a week is what happens. So you're exactly right.
I think now that we've firmed up the group, Bob, you can titrate the timetable to this group as you like, around your ABA and board commitments as well.
Okay.
So
It's just one of those things. It's a little hard to explain, but it's a huge commitment. It's 2 days in a row and whatnot. But yeah, let's keep that. But if you decide among yourselves that you want to do it in 2 weeks rather than 4 weeks, just contact me. Let's see. Let's take the bull by the horns. So we're talking about today's 11th. That would be the 25th, correct? I mean, you're 26th.
in terms of the fortnightly, yeah.
So just let me know. If you talk among yourselves, do your own little poll or whatever, and you say, I want to stay on top of this in 2 weeks works better, just email me. And then I think we can make that happen. I think I'm available then. I'm happy to do it kind of once we have a little momentum, if you will. And in the meantime, obviously download it, play with it, look at some of their intro YouTube videos. They're helpful. And just play around with data and go up to that data set, double click on data and start playing with it. There's no substitute of getting your hands dirty with data.
You've just had an offer, Bob. So Viren in this group is a Microsoft architect. And he's just offered to be your tutor to answer questions if their need arises. So he deploys commercial algorithms, blah, blah, blah. My comment that I wanted to say previously was the students that you'll have are insanely epic, Bob. So it's an intersection of people that deploy commercial level algorithms, senior educators, senior researchers, junior researchers. And I think we should pitch at the tempo of the slowest person in the room, which is probably, someone like me. But I think the opportunity in this little space and group is that you can, through Orange as a vehicle, tickle the entire journey of data to deployment of an algorithm in the one group. And everyone has experience at different levels with each. So it's going to be fascinating.
Yeah, well, the good news is we're not going to do it the way the computer scientist would do it, which would be to teach you linear algebra so you could understand how some of this works, because that would leave a lot of people behind. The same would be true of programming language. I will guarantee you there will not be anything so complex that you can't do it, and I'll stand by that. So I think you'll be amazed how easy this is to do. And it's not perfect, but it's the best that I've found by far. So if you want, we want to shoot for 2 weeks then? Is that the consensus?
I think for the
Oh.
next session, for the
Yeah.
next session, I vote, let's do it for 2 weeks. I mean, some people miss this. It's good to refresh that. It's a beginning. And then we can go up and down.
Okay, and we've recorded
I'm
this.
happy to meet in 2 weeks. That's fine by me.
Okay.
Yep.
All right, well, I'll schedule that and I'll send Zayden the invitation and we'll get that information out and do it that way.
They're
Now,
all going to, sorry, can I just ask, they're all going to be recorded though? Is that correct?
Yeah, the only question I have is I have to look at my Zoom account about how much memory they give me. I do have the option, I think, to download it. So I probably can put it on my Google Drive. I'll have to see, I'm not sure, but I don't want to run out of Zoom memory of whatever they allow, but that's the only issue I could think of.
Yeah, because I personally, I'm not going to be able to make every 2 weeks. So